Well, hello Internet, and welcome to my Elixir video tutorial. In this one tutorial, I'm going to cover pretty much what you would learn about Elixir in a standard 300-page book. I'm going to cover the core syntax and the language from which everything else is built. In the description underneath the video, you'll find timestamps to all of the different parts of what I cover in this tutorial, so you don't need to watch it all at one time. You could watch it and then come back to it and take your time. Also in the description is a link to all of the code in this video, as well as a cheat sheet, and it is heavily commented, and you should get it and take notes as you go through it to properly learn this language. And also inside of there is a link to a tutorial on how to install Elixir on both Mac OS and on Windows. And I have a lot to do, so let's get into it. Okay, so I'm using Atom, just like I showed you how to use whenever I showed you how to install Elixir, and I have either the terminal or the command line if you're on Windows. Everything works exactly the same. And I have a file here. I called it elixirtut.ex. I don't know if I put this over there. You can see elixirtut.ex. And I'm just going to start writing code. So the very first thing you're going to do is you're going to create your module, which is going to hold all of your functions. And to do so, you just go define module, and you can see everything popped in there. I'm just going to call this M just to keep this nice and short. Now, functions that you're going to define are going to start off with def. And then you're going to have your function name. Now, you normally don't have a main function in Elixir. I'm setting it up this way, however, to make it easy to work with. Now, what I want to do is I want to ask the user for their name, and then I'm going to output it. And how we receive input from our user is we go IO gets, and then you can put either parentheses inside here or not put parentheses. I'll use parentheses. Sometimes I'll use them, sometimes I won't. So I'm going to say, what is your name, and put a question mark and a space, and then outside of this I am then going to trim off the new line. And to do that, you just go like this, and you go string and trim, and that'll get rid of that new line. So now we have their name, and it's stored inside of the variable name. And basically, variables are going to start with lowercase letters or underscores, and then they're going to contain uppercase letters, underscores, or numbers. So if I want to now output this information, I go IO puts, and here I won't use parentheses, and I'll go hello. Then I can use string interpolation, or it just provides a way for me to take the variable name and insert it inside of this string that I'm going to output on the screen, and I'm going to put name inside of there. And as you can see, there are no semicolons, no periods, no nothing. And if we save this, now we're going to go over into the terminal or command line, and I'm going to type in IEX, and you can see everything loaded up there nicely for me. Also, I'll cover this. If you want to abort or get out of this, you just hit Control-C and then A, and you're out of it. Obviously, you want to make sure you're in the directory where you have your file, so there that is. And you would type in dir on Windows if you're using Windows instead. And what I want to do here is clear that out again. So I'm going to go IEX so we can execute this. And then we're going to put in C with a quotes around the Elixir tut part here. And then we're going to come in and go module name followed by the function we want to execute, which is main. And it says, what is your name? And I type in Derek, and then it says, hello, Derek. Okay, so really nice, simple little application we can run here. So now let's go and do something a little bit more complicated. I'm going to call another function. I'm going to call this data stuff and call this function, and then we're going to create it down below. Let's get rid of this so we don't junk up our screen with all this extra code. So come down here and create a new one, and what we're going to talk about now are the different data types. Now basically you're going to use the different data types such as integers, floats, atoms, ranges, binaries, lists, maps, tuples, and a couple other different ones. I'm going to cover all of them in this tutorial. And once you set a variable's value, that value cannot change. So let's first off start with an int. Well, first off, let's create our function. So I'm going to go define, and I'm going to call this data stuff and do. And then inside of it, we'll go and create an integer. I'll call this my int is equal to 123. And if you want to find out what type of data it is, you just go IO and puts. This is going to output it, and we'll say integer, and then we will go and check if it is an integer and throw my int inside of there. And I'm just going to compile this. It gave me a silly warning. Don't worry about it right now. And then I'm going to come in and execute it, and you can see integer true comes back right like that. Let's go and do a similar thing with floats, and it's also important to understand that with integers, there is no maximum integer size. So let's create a float here instead, and 3.14159, and we'll check if this is a float. And you can do this with all the different data types. Here I'll just go is float, and I'll go my float, and execute this guy. We'll save it first, jump over here, compile, and run, and you can see that float true comes back. You're also going to be able to work with atoms, and an atom's name is going to be the same as its value. So let's just come in here and let's just create an atom directly inside of here. So I'm going to say atom, and I'll say is atom. I'm guessing you probably was guessing, and this is an atom right here. So Pittsburgh is an example of an atom. The name for it is exactly the same as the value. And I'm going to show you a whole bunch of examples here that are going to make all of this make a lot more sense. So let's come in here and do that. And you can see atom true comes back. Also, it's important to know that if you want to use spaces inside of your atoms, you're going to put a colon like this and then double quotes. And let's say you wanted to use New York. There you go. Once again, the name is the same as the value. And likewise, you're going to be able to define ranges. And here I'll just define one, but I'll show you later on how to use them. So you go 2 to 10 is going to be equal to, and you go 1, and then 2 dots, and 10. All right, so that's the basics of the most basic different data types that are available to you. And now I'm going to talk about strings. All right, so I'm going to change this function name to do stuff and do stuff just to keep it generic. Now, basically, strings are going to be defined with double quotes. So we'll go and create one. We'll call this my string is equal to, and my sentence, and there you go. You got yourself a string. Now, you're going to be able to get the length or number of characters inside of your string just by using length. So I'm going to go IO puts, and I'll put length inside of here, and then I'll go and get that length. And to do that, you have to type in string followed by length, and then you throw in whatever your string name is. And I'm going to execute these. I'm going to do a bunch of these, and then I'll execute it all at once. We're also going to be able to compare strings, or actually I'm going to show you how to combine strings first. So let's go and let's create another string. Let's call this longer string. And to combine it, we're going to go my string. And this is how we combine or concatenate strings. Put a space inside of there, 2 more of those brackets, and then I'm going to say is longer. And there you go. Now you have a longer string. Let's also come in here and let's compare a string. So we'll say, let's see if these are equal to each other. And you can do all sorts of things inside of here. With string interpolation, you can execute different things and so forth. So I'm going to have an uppercase version of egg, and then I'm going to use 3 equals. What that does is it checks to see if the value as well as the data type are equal whenever you use 3 equals. If you just have 2, it's going to check if the value is equal and ignore the data type. So I'm going to use lowercase egg here in that situation. And let's run this and let's check out what's going on. Once again, don't pay attention to the little warnings that I'm getting. And you can see here the length comes back as 11 and the equality comes back as false. Why? Because that's an uppercase E, this is lowercase e. All right. We're also going to be able to come in here and check if a string contains another string. So let's output this on the screen again. So I'm going to say my. Is my contained inside of here? And let's go and verify, check that. We're going to use string again, and we're going to say contains, and you're going to put a question mark here at the end, and you're going to say, does my string contain the word my? And we'll execute that in a second here, and you'll be able to see exactly how that works for us. You can also return the very first character inside of here. So we'll say first character is what we're looking for, and we'll say call the string, and we'll say first and my string once again. We're going to be able to get a character at a specified index. So we'll say, what is at index 4? To get that, we go string at, and then you pass in the string that you want to search through and the index specifically that you're looking for. You're going to be able to get substrings. So we'll go substring. And then inside of this, again, we're going to use the string library here, or string module, and its name is slice. And to get it, you go my string, the string you want to work with, the index you want to start at, and the number of characters after which that you would like to work with. And we'll come in here and we'll execute it, and you could see, is mine the string? True, yes it is. What is the very first character? M. What is at index 4? E. And you can see here we started at the third index in. This is 0 based, so this is going to be 0, 1, 2, 3, and then we wanted to get 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so pretty neat stuff. We're also going to be able to come in here and split a string into a list. And what we're going to use here is inspect. And what inspect does is it prints the internal representation of a value. So what we're going to do is we are going to split the long string with at the point in which there's spaces inside of it, and we're going to convert it into a list. More on lists later on. But inspect is going to allow us to sort of see what that internal representation of a list looks like. So we're going to go a longer string, and then we're going to define what is going to split all of those guys. And we'll wait a second here, get a couple more things going, and then look at that output. You're going to be able to reverse strings. So let's go and reverse this guy. I'm going to go string and reverse, and we'll throw a longer string inside of there. We're going to also be able to use uppercase. So let's do that. This is going to be just all we need to do is come in here and get this and change this to uppercase. We're also going to make all the characters lowercase, and to do that, we type in downcase. We're going to be able to capitalize just the very first character and have everything else be lowercase. So capitalize, and that gets you that. And also something else that's kind of neat to be able to do is to know that you're going to be able to pipe values from one thing to another. So let's say I want to multiply 4 times 10, and then I want to pipe it to a different function. We'll do more examples of this later on, but basically go like this. And let's say I wanted to perform this code. I want to execute this code, and then I want to pass it to puts so that it outputs it on the screen. I can do that. And this is very functional language. And we'll run it, and it will execute it. And you can see all the different things we did here. This is the list representation inside of Elixir. You can see that was printed because we used inspect. You're going to see here we went and reversed everything, uppercase, lowercase, capitalized, and then 40 comes back because we went and performed this calculation and then passed it to puts. Okay, so that's a rundown of a lot of the things we can do with strings. Now I want to show you briefly some of the things we can do mathematically. And there you go. I went and put these in here a little bit to save some time. We're going to be able to add values, of course, subtract, multiply, divide. This is going to be division, integer division, so it's going to get rid of any decimals. And rem is the same as modulus. It's going to basically give you the remainder of a division. So if we come in here and we execute that and we run it, you're going to see all of the output right there for the math functions. And there are tons of math functions, logs and power functions and e and all of different cosine signs and all those other different things. I'll leave that to you to go and look up on your own. And now what I want to do is jump in and talk about how we can compare values using Elixir. All right, so what we're going to do here is we're going to, well, I'll show you whenever we use just double equal signs. And what we're going to do is compare integers to floats. And, whoops, let's get rid of that guy, right? Whoops. All right, and then what we're going to do, throw that there like this. And then let's compare these different values to each other. So I'm going to say 4 equal to 4.0. And we're going to be able to see the difference between equals and 3 equals. All right, so we'll do like this. And then we'll throw 3 equals inside of there. And then we're going to do a similar thing with not equals. Not equals has a similar way of doing comparisons. So I'll throw that inside of there. And then we will do another one, not equals, with the 2 equal signs. And we'll save that. Let's come over here, compile it, and let's run it. And you can see right here, whenever we use just the 2 equal sign, this comes back as true. Why? It's comparing the values and not the data types. And here we are going to be, whoops, I have to go in here and do this, obviously. Let's go like that, and I'll throw that new line inside of there. There we go. Now we're going to get the proper output that we were expecting. Get out ahead of myself a little bit. Let's run it. All right, so now you can see we were here just comparing the values and not paying attention to the data types, so that comes back as true. Here we were comparing the values and the data types. Well, this is an integer, this is a float, that's why it comes back as false. Here we were just comparing again the values, and this is not equals to. And here we were comparing the data type as well as the values, and that's the reason why that comes back as true. All right, so pretty neat stuff. Let's do some more advanced stuff. We can also come in here, of course, and check for greater than and less than and equal to and all those other different things. Let's change this a little bit. Let's change this to a 5 and to a 4, and we'll check if this is greater than. So come in again, 5 greater than 4, and we'll go and check a whole bunch of different things. So and greater than or equal to, of course. So greater than or equal to, and here we'll check less than and less than, and here we'll check less than or equal to and less than or equal to. Come over here, execute it, run it, and there you can see exactly how all those work. And I'm gonna do some more examples here, of course. Let's go and get rid of all that. And we'll talk about logical operators. So I'm gonna create a function here called age. 16, and what I'm going to check for is if this person is going to be able to vote and drive. So I'll say vote and drive, and then inside of here we'll get rid of this, and we're going to say if age is greater than or equal to 16, and I know this is bad logic what I'm doing here, I'm just trying to demonstrate how logical operators work. And the logical operator we're using here is AND. So I'm going to go in and I'm going to go age is greater than or equal to 18. And let's do another one that's similar sort of function. So we'll go like this. And here what we're going to do is we'll do exactly the same thing, and then we'll put or inside of there, or. And we'll say vote or drive. Okay, so what I'm doing is just providing two ways of checking different values. This is going to come back as true if this is true and this is true. And this is going to come back as true if either one of them are true. So we're going to come in here and we'll execute it and we'll run it, and you can see indeed how the output works out for those guys. And of course, the other logical operator that is going to be available to us is not. And basically not is just going to take whatever is true and turn it into false, and whatever is false and turn it into true. And there you can see, turned the true into a false. All right, so there is a whole bunch of different things in regards to how we can compare values. Now I want to talk about decision making. Now there are many different ways that we can perform certain actions depending upon different comparisons and so forth and so on. I'm going to show you a whole bunch of them here. So of course we have if. So what we're going to do here is I'm going to say if age is greater than or equal to 18, we'll then do whatever is inside of these brackets. And what we specifically want them to do is to go and output can vote on the screen. Now, let's say we want to check another condition. How can we do that? Well, we can just come in here and we can come back out to the side and we'll say else. If that's not true, in that situation, what are we going to do? We are going to output that they can't vote. All right, so that's the ifs and else statements and exactly how they work. Let's do a couple more here. There's also unless. With unless, the code is going to execute unless the age is going to be equal to 18. And we'll do this. Paste this inside of here, and in this situation, I'll just say you are not 18, and we'll come in and we'll do an else statement, and in this situation we'll say you are 18. And let's do another one. We'll do the conditional. Basically the conditional is going to work like else if, and it's very important to understand, however, that it is only going to hit or produce output on the very first match. So what we're going to do here is we're going to say condition do, and then we're going to list a whole bunch of different conditions we want to check for. So if the age is greater than or equal to 14, then we want to execute specific code. And the specific code we want to say is, in this situation, I'm going to say you can wait Throw that in there. And then we'll throw in another condition. So we'll say age is greater than or equal to 16. In this situation, we'll say you can drive. So you can drive. And then we'll throw in another condition. And this is going to be age is greater than or equal to 18. Just know that when it hits one of these, it's going to output this. So whenever it hits this guy, it's going to say you can wait even though the age is set as 16. So putting these in the proper order is very, very important. So actually, I should have put the 18 up here and but I'm just going to do it this way. So yeah, let's just come in here and do it this way. You can vote. And then if you want to have a default action that is always going to be true, you just put true inside of there, exactly like that. And then we'll say default inside of here. So we'll say default. And why don't we go and run this, because we have a whole bunch of different things to check out. It throws up all kinds of warnings, so don't worry about it. And executes. And you'll see right here for this if-else statement, it's going to say you can't vote. The age is 16. All right. Down here for the unless it is 18, you're going to see you're not 18. Here you're going to see you can wait. And the reason why is because this is 16. Like I said, in actuality, let's fix it. Let's just do it the right way. We'll throw that there, and then we'll throw, I did it that way just so you can see that it will foul up if you don't put these in the proper order. So let's go and get rid of that. And now we can run it again, and you'll see that it does it the right way. And you can see here it comes back as you can drive. All right, so there's even more. I'm going to show you more. So let's go in here. Let's get rid of this. Many different ways to perform actions depending upon conditions. There is also going to be the case statements, which are going to work like switch in other programming languages. So here what we're going to do is we're going to say case 2. You could have a variable inside of there, but I'm just going to put the value of 2 inside of there just to keep it simple. Here I'm going to say if that value is equal to 1 in that situation. Let's go get rid of that. I'm going to say entered 1. And if otherwise it is 2, I'm going to come in and I'm going to say entered 2. And then once again, if you want to have a default, what we're going to do is just put an underscore inside of there, and then we'll go and put something inside of here like default. Default. Okay, so there are case statements. And the very final one is the ternary operator. I'm going to show you how to set up a ternary operator inside of Elixir. So what we're going to do is I'm going to say ternary, and then inside of here, I'm going to say if age is greater than 18, and then I'm going to put a comma inside of there, and then do, and you're going to define what you want to be done. And otherwise, I can put an else statement directly inside of here. In that situation, I'm going to put can't vote inside of there as the other option that's available to us. And we'll come in here, and we'll run it, and we'll execute it, and you can see the ternary operator worked. Can't vote comes back, and you also saw entered 2 comes back with the case statement. Okay, so whole bunch of different decision-making tools available for us inside of Elixir. And now I'm going to take a look at the tuples. Now, normally tuples have 2 to 4 values inside of them, and they can hold any value. However, they are not for enumerating through. And what I mean enumerating through, I mean that you're not supposed to cycle through tuples or go and check for values one by one by one. Here, I'll just show you examples. So I'm going to come in here and I'm going to create my stats is equal to, and I'm going to say 175 and 6.25, and then I'm going to throw an atom inside of here that is Derek. Now I'm going to output some information on the screen. Let's say, well, first off, let's check if this is a tuple. And to do so, we go tuple, and then I'm going to check if it's a tuple. How do you do that? See if you remember. Is tuple. Pretty easy to remember. And I'm going to type my stats inside of there. And we'll do a couple more things. You can also append values to a tuple, but remember, every time you go and make a change, you have to change it and save it to a new variable. So I have to go my stats, because once a variable receives a value, it stays, it's permanent for forever. So you can add these functions, you can go and add on or append values. However, you need to create a new storage area for it. So I'm going to go my stats, and let's say I want to throw 42 into that tuple as well. Well, with append, we can do that. You can also retrieve values by index. So let's say I want to go and get age from it. I can go age, and to do so, you go element, and you pass in my stats 2. Oh, let's go and throw this in here like that. My stats 2. And I want to get whatever is in the third index. Again, this is going to be 0, 1, 2, 3. This is the one that I appended on there. We're going to be able to get the tuple size. Let's go and get our tuple size. And here you just go tuple once again, size, and you pass in whatever tuple you want to work with inside of there. You're also going to be able to come in and delete an index inside of a tuple, but once again, you're going to have to store it in a new data area. So my stats 3 is going to be equal to, we're going to say tuple delete at, and you're going to pass in whatever tuple you want to work with. So this is going to be my stats 2, and I'm going to say that I want to delete the whatever is at the 0 index, and we can also go and insert at an index. We're going to do almost exactly the same thing. Once again, got to create a new storage area. So I'm going to go my stats 4, and it's going to be, instead of delete at, it's going to be insert at. And I'm going to go and have my stats, let's change this to my stats 3. And what you need to do here is define the index you want to work with. I'm going to say it's the 0 index, and then I'm going to say the data that I actually want to input inside of it. And we're also going to be able to create a tuple with the same values duplicated a certain number of times. So let's go and create something called many zeros, and do this. We'll go tuple and duplicate 0 and 0 5 times. So it's going to create a tuple that's going to have 5 zeros inside of it. And finally, you're also going to be able to use tuples for pattern matching. So I'm going to be able to do something like type in weight and height and name and pull out that data. So I'm going to go 175 and 6.25 and Derek the atom. And then we can go, well, don't want to do that. I want to get this guy right here. Yeah, just grab that, throw that inside of there, and we'll change this from size to weight, and then we'll just throw weight inside of there just so you can see how that works. So there's weight, and we can come over and we can execute it, and and here you can see, whoops, spelled tuple wrong. That's all right. And you can see up here, let's go get rid of that right there. Not that it matters. All right, so here we're checking, is it a tuple? Yes, it comes back as true. Here we are appending the age of 42 to it. We're then checking the age. See it, 42 comes back. We are then checking the size of our tuple. You can see that there's 4 pieces of data inside of it. And then down here, we went and pulled or assigned the 175 to the weight and then output that on the screen. Okay, so a whole bunch of things we can do with tuples. And now we're going to talk about lists. All right, so lists are going to contain lists of data of any different data type. So what I'm going to do is I'm going to create 2 lists here, and you just go and surround the data or whatever values you want inside of brackets. So I'm going to go list 1 and list 2, 4, 5, and 6. And if you'd like to combine 2 different lists, you can do so. Just go list 1. Then you're going to put 2 plus signs and list 2. And there you go. Now you have a bigger list. You can also go and subtract a list from a list. So we'll go list 3 and put 2 minus signs and list 1. You can verify if an item is inside of a list. So let's check if there is a 6 in list 4. You can separate the head, which is the very first item inside of the list, from the tail, which are all the other different items, just by going like this. So we'll say head and tail. I'm going to put some spaces inside of there so it's a little bit easier to read. And we'll say we're going to perform this operation on list 3. And let's go in here and let's output the head for this guy. So we'll go head, or the very first item in the list. That's what the head is. You're going to be using this a lot. So let's go and get that guy. And then let's go and, I didn't cover this yet, so I'm going to use it. You can also output data using write, and how write works is it doesn't put a new line after it outputs the data like puts does, so that's also something nice to know. We can also come in and use inspect to output tail, which is going to show a representation of the list inside of here. Let's go run that, and here you can see we come back as true. And where that comes from is we checked if there was a 6 in list 4. We went and grabbed the very first item out of the list. That's the one. Tail is all the other different items that we have inside of there. And then here we printed out the tail on the screen. I've been using inspect here and want to point something out. It is possible. Now, like I said, inspect is going to print the internal representation of a value. But it's important to understand that it may give you odd results. So let's come in here and we'll throw 97 and 98 inside of there. And let's see what happens. So basically, we run it. And you're going to see that we get AB, okay? It printed character codes inside of there. If you want to guarantee that it is going to print the list and not character codes, what we're going to do is put a comma inside of there, character lists, and then we say as lists. And if you do that, then you don't have to worry about it outputting bad data. And you can see that it printed 97 and 98. The AB part there is just going to be basically what happens with Elixir, like Erlang, is whatever the last value inside of the function is going to print out on the screen. Okay, so there's that. All right, just in case you come across some problems with inspect and you want to fix it. You're also going to be, with lists, be able to enumerate over lists. And to do so, we can go enum and each. And I'm going to say tail fn item. And we can come in here and output the individual items as we come across them. Item, and then close that off with end. And if we run that, you're going to see it goes and prints out all those different items. Let's go and create another list of words. So I'm just going to call this words. And I'm going to say random words in a list. And then let's enumerate through these again, or cycle through them. So I'm going to go words is going to be what we're cycling through. And then I'm going to go fn and word. And then what I want to do with them as I cycle through them. So let's go and output them. So I'll just go word and then end that. And you can see it goes and outputs all those. Okay, so you can cycle through numbers, words, doesn't really matter. Another thing that's kind of neat is we're going to be able to use recursion to loop as well. So I'm going to create a function and it's going to be called display list. And I'm going to pass it my words list and have it cycle through all those. And whenever we're talking about recursion, what we basically just mean is we're going to be calling the function from inside of itself. So let's go. I'm going to show you a whole bunch of examples of recursion. I'm just going to give you a brief example here just to show you how to use recursion to cycle through a list. So this is display list. To make sure you do this, you create this new function outside of that area. And this guy is going to be passed in the words, the whole entire list. And what it's going to do is it's going to actually break the head and the tail apart right here inside of there. I'm going to go do, and then IO, puts, and word. So it's going to break off the head and it's going to output it on the screen. And then it's going to call itself, so display list again, pass in word, it's going to break off the head, output it, and so forth and so on. One thing is you're going to have to, whenever you're using recursion, always have an ending, a situation in which it no longer calls itself. And we're going to give this the same name. It's going to be like if the display list is called with an ability to break off the word like we did here and output it, well then we're going to call this function. If, however, it is ever passed an empty list, well then in that situation we're going to use this display list, and under that situation what we're going to do is nothing. So how do we do nothing? Well, to do nothing, you're just going to put a comma inside of there, and then we're going to go do, and we're going to go nil. All right, so here we're calling display list, passing it inside there, and then we're going to cycle through, break off the heads, print them out, and Let's get rid of that. Let's run it. Whoops, gave me an error. What's the problem here? It's saying there's an error on 45, unexpected token end. Whenever I originally created the display list down here, the second one, it threw another end inside there. So we got rid of that. And we'll run it. And now you can see it also is another way for us to print out all of those different words in a list. And we'll do more with recursion as the tutorial continues. Now we're also going to be able to come in here and delete given items from a list. So I'm just going to go IO puts and show you what it looks like. So we'll say display list, and then I'm going to go list delete words, and I'm going to delete random out of our list and then pass it in to display it on the screen, and you'll see how that changed. And here you can see it doesn't show random in that situation. Okay, so good stuff. You can also delete an item at a specific index, and to do that you go delete at. Once again, we're going to pass our list inside of here, but I'm then going to pass in an index, and here I'll say that I want to delete whatever is in the one index. And there you can see random in a list, say it got rid of the words. We can also insert an item at a list, and to do that we go insert at words, and we'll change this to 4, and that's going to be at the end of the list. And then we'll say we want to put the word yay or something like that, and run that, and you can see yay shows up there. We're also going to be able to get to the very first item inside of our list. So let's change this a little bit. Let's just get rid of that altogether. We'll type in list and first and what we're specifically searching for. We can also get the last item inside of there. So we're going to do pretty much exactly the same thing. Go right there, and we'll change this to last instead of first. And the final thing is you can actually create lists of key value tuples. So to do that, you can say something like name, and then Derek, put a comma, height, and 6.25, and 6.25, and whatever. Okay, so you can go and experiment with that on your own. So there's a rundown of lists. Now I'm going to jump over and talk about maps. Now a map is going to hold a collection of key valued pairs. So let's say we want to do something like create a map called capitals. What we're going to do here is put a %, and then we're going to define our keys and our values. So I'm going to say that Alabama is going to be my key, and the value assigned to that key is going to be Montgomery, okay, which is the capital of Alabama. And we can go down here to different lines. It doesn't matter. You can indent whatever. Everything still works. Let's go and create another one. We'll say Alaska, and we'll say Juneau. And why don't we go and create another one? Well, put the comma inside of there. And then we'll go Arizona. And then let's go and create a value assigned for that. And that's going to be Phoenix. All right, so there you go. You just created a map. Now you're going to be able to retrieve values using a key. So we'll say, let's say we want to get the capital of Alaska and output that on our screen. We'll say is, well, we can just go capitals like that, and then pass in whatever your key is. Like do some more stuff. Let's say, well, you can also use atoms as keys, which is nice to know. Well, let's go and copy this and just use atoms instead of strings. So we would be able to come in here and we'll change this to capitals 2, and then let's change this to Alabama. And then what we're going to do is we're going to put a colon inside of there, get rid of this guy altogether. And we would do that for all of these different guys. And let's go and just do it. So we'll say Alaska, that in there, and Arizona, put a colon inside of there. And now what we'll do is we'll actually access these in a slightly different way. So we're going to go puts, and we'll say capital of Arizona is, and we'll go and get it. Like I said, you're going to do this in a slightly different way. You're going to go capitals 2, and then follow that with a key. So dot Arizona. And also you'll be able to insert key values inside of here, but once again you have to create brand new maps. So we'll call this capitals 3, and to do so you go dictionary, put new, and capitals, and let's say you want to throw Arkansas inside of here. You can do that like this, and then follow it up with whatever the value is, Little Rock. All right, so got that inside of there, and we'll come in and run it, and there we go. And you can see how all that information printed out on our screen. Okay, so pretty neat stuff. So there's a rundown of maps. And now I want to talk about pattern matching. Now, I already talked about pattern matching a little bit. I just want to give a brief example here. So basically, with pattern matching, we're going to be able to retrieve data from different types of data structures. So let's say we want to go length like this, and then width. We're going to be able to assign those to whatever is inside of the data structure, which in this situation is a list. And then we're going to be able to automatically go and print out that information just by referencing the variable that we put it inside of. You saw this before, but not with lists. It's also important to know that you're going to be able to work with more complicated systems. And what we're going to do whenever we don't care about the data is we're going to put an underscore inside of it. And actually what we're going to do here is try to match up a list inside of a list. So we're going to have a list that is also going to have a list inside of it. So how we match those different guys is we just basically copy exactly what's there. So let's say we don't care about what the first item in the list is. Well, there that is, but we do care about that item. So we throw that inside of there. And what we're going to be able to do is go and get that value. So we'll just say get num. And if we come in here and we run it, you're going to be able to see there's width. It has the value of 30 and get num is 40, which is what it grabbed there. Okay. So neat stuff. More with pattern matching as the tutorial continues, but I want to also talk about anonymous functions right now. Now, basically, an anonymous function has no name and it can be passed to another function, which is extremely useful. So let's go and create an anonymous function, and we'll have it assigned to the variable getSum, and getSum then could be passed into a function. And what it's going to receive is an x and y value. And what it's going to do is it's going to add x and y together. All right, that's all you got. Now you got an anonymous function. Now what you're going to be able to do is throw it around just like it is any type of variable. So what we're going to do here is we're going to go IO puts. I'm going to say 5 plus 5 is equal to, and then we'll be able to reference that. We'll go get sum, and then you're going to put a dot like that. And then you're going to pass in whatever the parameters are you want passed to that function. Whoops, 2 of these extra things slipped inside of there. So get rid of that. And there you go. And well, we're going to do a couple more here so you can see them all execute at the same time. There is also a shorthand of the above. So let's go and create another one of these. Let's call it get less. And what you're going to be able to do here, I'm going to model it in much the same way. You're going to be able to go like that. And then 1 and negative, throw another and sign inside of there, and 2, and that is exactly the same as if you typed all of this stuff out. And basically, if you wanted to subtract another value, you just put in there and go 3. Okay, but I just want to keep this to 2. So this is just going to subtract those values. It just provides another different way to see the same thing. In a shorthand notation, it might not be so obvious. So in this situation, what we're going to do is we're going to go 7 minus 6, and we'll go call get less, and then we're going to pass 7 and 6 inside of it. So there's 7 and there's 6, and we'll save that. And let's do another one here. I think you can see what's going on here. You can also have functions accept different numbers of parameters, which is very, very useful. So let's say that we wanted to have a function called addSum. However, it is going to receive an unknown number of attributes passed inside of it. So what we want to do is we want to have this work. So what I want to do is come down here and type and what I'm going to define is with the function addSum, what are we going to do if we receive 2 values? Well, in that situation, what we're going to do is we're going to call IO puts, and we're going to add those values together. So we're going to go and throw x inside of here plus, and then we'll throw y inside of there like that is equal to, and x plus y. All right, and in the situation in which we receive 3 values, well, we're going to have a solution for that as well. We're going to have x, y, and z, and we're just going to change this to plus and throw the z inside of there, and then let's throw the z inside of there. And we can come down here and we will be able to work with those. So to call those functions, you just go addSum like that, and then a period, and then you're going to throw in whatever your attributes are. And then likewise, you're going to do exactly the same thing, but here we're going to call add sum, and the only thing we're going to need to change is the additional value we throw inside of there. And you can also set defaults for your parameters. Let's go and save this and let's execute it. And there you can see how all of those outputted on the screen and everything works just perfectly fine. One other thing I just want to demonstrate here real quick is you can also set defaults for your parameters for all of your different functions you work with. So I'm going to output here first a function called doIt, and I then have to create doIt, and we'll come down here. Let's just create doIt. So we'll go define and doIt. And if you want to have default values, all you're going to do is go x, which is going to be your attribute that's passed inside of here, 2 backslashes and a 1. That's going to give x a default value of 1. Let's go and throw another one inside of here. Let's go and give y a default value of 1. And then we'll go do. And then in this situation, we'll go x plus y. And we'll come over here and we will execute this guy. And there you can see the 2 comes back. All right, so a rundown of how we can use default values, how we can use anonymous functions, and a whole bunch of other different things. And now I'd like to talk about recursion. All right, so as you saw previously, recursion is just a situation in which a function is going to call itself. So how we normally demonstrate recursion is through the use of factorials. So here what I'm going to do is I'm going to call a factorial function that we're going to create here in a second. So we go factorial of 3, and then we're going to call our function, which we're going to create here in a moment. I already showed you how to use recursion to loop through different lists and things like that, but let's go and create some more things. So how we're going to demonstrate, let's go and put the factorial function right here. We're going to create a new function, obviously, and we're going to call it factorial, and it's going to receive a number and throw the do inside of there. And what it's going to do is we have to have a situation in which we're going to end the calling of our function. And to do that, I'm going to say if the number is less than or equal to 1, well then I'm going to return a value of 1. Otherwise, go throw an else inside of there. I'm going to calculate our factorial. So we'll go result is equal to num times, and then we'll call factorial, which is the function calling itself, and that's going to be num minus 1. As you can see, eventually num is going to get a value of 1 because we are subtracting it, no matter how big we make it. And then if we want to return a value, we just put the value itself inside of there. That's it. Very, very simple factorial. Now let's run it, and then I'll explain exactly what's going on. So like this, let's run that, and there you can see factorial of 3 is going to be 24. Oh, why'd I put 4 there and then let's go and put this right here. Let's save it, and let's run it again. All right, so where we go, and factorial of 3 is going to be equal to 6. Let's do 4 instead, because I think that will just give us a little bit better idea what's going on. So let's throw it in, run it, and run it. Okay, so how did it calculate that? Well, basically, what happens here is we call our factorial function, and we have a value of 4 inside of here. So you get a value of 4 right here, times factorial of 3. This is it. So 4 comes in, the 4 goes down to here, and we multiply that times factorial of 3. What's that? What then happens? Well, we jump down to this line. We take 3 times the factorial of 2. Factorial 2 jumps us down here. 2 times the factorial of 1. Well, here's the value of 1. It says if number is less than or equal to 1, return a 1. Okay, so this is 1. So here what we're calculating is 2 times 1. 2 times 1 is equal to 2. This 2 jumps up here, jumps there. 3 times 2 is equal to 6. We take this 6, throw it up here. Then we take 4 times 6 is equal to 24. And that is an example of how we can calculate a factorial using recursion. And now what I'd like to do is demonstrate how looping works inside of Elixir. Okay, so with most languages, we loop by incrementing or decrementing a variable. However, since all variables are immutable inside of Elixir, we're going to use recursion to loop. And I'm going to give you a demonstration of how this works. So IO puts, and I'm going to say sum. And what I want to do is I want to sum all of the different values that are inside of a list. How do we do that? Well, we can show you right here. So I'm going to go and get 1, 2, and 3. And using Recursion and Elixir, I'm going to show you how to easily sum all of these values. And then after that, I'd also like to show you how to create a loop in Elixir. So I'm just going to call this function loop. That is my name. It isn't a built-in thing inside of Elixir. And now I'm going to jump down here and create both those functions. So let's come down inside of here, outside of our main little function, and we'll go and sum all the values. So what we need to do anytime we use recursion is we need a situation in which we will no longer continue calling a function. And we're going to define that if our sum function receives an empty list, in that situation, it is going to cease to call itself. And instead, it's going to return a value of 0. Now we will create our sum function that is going to work for all their situations. And we're going to say if we get a list inside of here that is not empty, we want to get the head and the tail. And then what we want to do with it is we want to go do, and we want to say h plus, and then we want to call the function back again, passing in the tail. And we'll continue doing that until the list is empty, and in that situation, we will return a 0. Okay, so you see up here, we passed in the values of 1, 2, and 3. Come up here, whoop, gave me an error. Ignore all the red stuff, just jump up here. And it says there's an error at 10. Oh, it's giving it. All right, so let's go and create our loop function, or better yet, did I tell you what comments are? That's how you use comments. You throw in a hash symbol. All right, so let's come in here, run it again. And there you can see the sum is equal to 6. Okay, so the sum functions work. All right, pretty neat stuff. So now what we're going to do is have a little loop work. All right, come down here, and we'll leave some in there. Looks nice. Now to create a loop, what we're going to do, once again, is we are going to say when we are going to leave our loop recursion calling functions. And when that's going to happen is when a value of 0 gets passed inside of here. I don't care about what the other thing is, so I'm going to throw an underscore inside of there. And then I'm going to go do, and then whenever this, I'm going to return a nil. Now I'm going to create the meat of our loop function that is going to loop through. What it's going to do is it's going to receive a max value and a minimum value. We're going to be doing some really neat things with this later on whenever we talk about concurrency. All right, so then what I'm going to do inside here is I'm going to say if max ever reaches a situation in which it is less than min, well, in that situation, I am going to come in here and I'm going to say loop, call the loop function, and pass in a 0. That's going to call this guy, and that's going to end everything. It doesn't matter what I put inside of here, but I'm going to put min inside of there just to do something. Otherwise, I'm going to say else, and in that situation, I'm going to output whatever is inside of there. So this function is basically going to receive a maximum value and a minimum value, and it's going to go and count through those until there's nothing more to do. So I'm going to go num, and you're going to be able to cycle through lists or do whatever you'd like. I'm going to talk more about enumerables though here in a moment. So I'm going to go max, and then I'm going to call the loop function again, and I'm going to take max minus 1 and pass in min once again. So what's this saying? It's saying it wants to count from 1 to 5. Maximum number, minimum number. So let's save that. Jump over here and we'll run it. And there you can see it goes and starts out at 5 and decrements down until it gets a value of 1 and then it leaves. Okay, so an example of how we can loop with Elixir. And now what I want to do is talk more about enumerables. Okay, so now let's talk about enumerables. And what we mean by enumerables is a data type that is going to allow its items to be counted off. So what we're going to do here is we're going to check if all values are even inside of a list. Sounds like something would be pretty complicated, but it's pretty not complicated. So what we're going to do is I'm going to go even list, and lists are going to be a situation, a data type that is going to be able to be cycled through. So to do so, what we need to do is go enum all, make sure you put a dot inside of there, all, and question mark, and then we are going to throw in a list. That's going to be 1, 2, and 3. And then after that, like this, let's go down to the next line. We need to define what we're going to do inside of here. So we go fn, and we go n, and for each of these different items inside of our list, we're going to go with the remainder, n and 2. So we're going to take the value of each of the list values, and we're going to use the remainder function on them versus 2, and we're going to check if they are equal to 0. If they are, if this condition right here is true, then they're going to go in our new list and print them out. If not, they're going to just simply be disregarded. And then what we need to do here is throw an end in there to end our function. So pretty simple, straightforward. Let's run it, and you can see even list comes back as false. And what we're doing here is just checking whether all of the values inside of our list are even or they're not. We'll get into how we can actually output the actual items. We could also, let's go and check. Let's do a copy of this. Let's just change it. So let's check if any of them are even. Okay, all we needed to do there was just change that to any, and we can run this, and there you can see it comes back as true. We could then go in and print out each of those different items if we would like. So let's go and do this, and we're gonna go enum each, and we will throw in our list 1, 2, and 3. And then we define what we want to do with them. We go and say each of the items inside of our list, we want to come in here and output it. So we're going to call puts. So we'll just pass that over into the puts function and end, and then throw end inside of there. And that's how easy it is to cycle through all those different guys and print them out on the screen. There you can see, nice and neat. Let's say we wanted to double each value in a list. We could do that as well. Let's go double list is equal to, we're going to call enum and map and pass in 1, 2, and 3, our list that we want to work with here. Jump outside of there. We're going to define fn and each of the individual items in our list, and then we're going to define what exactly we want to do with each of those items inside of our list. And let's do something even more complicated. Let's say we wanted to reduce down to a single value. So in this situation, we want to add all of these values together. We can do that. So let's call this sum values equal to enum and reduce. And we'll pass in the same function here again, 1, 2, and 3. After that, we then want to define what's going on. So we're going to sum all the values and store them in the variable sum as we cycle through. So we'll go n plus sum and end. And you can see just how quickly we can do things here in Elixir that are kind of complicated in other languages. And let's go and output our sum, and that's going to be sum values. And then let's also come in here, and you'd also be able to use a function called unique in the enumerable module that's going to spit back a list that is only going to contain one of or no duplicates inside of the list. So we'll go enum and unique, and then we'll throw some duplications inside of there just so you can see what that looks like. 1, 2, and 2. All right, and we'll do this, and we'll do this, and then we'll come in and we'll run it. And you can see right here, we were able to print out all those different items. That's done with this guy. You can see we were able to cycle through and sum all those different values together. Or actually, I didn't print that out. Let's go and print that out. So we'll go, I don't want to use puts here. I want to use inspect, or yes, inspect with this one. So I'll go IO inspect and double list, and we'll run that again. And there you can see, went and doubled all the values in the list. You can see reduce was used here to add all those values and condense them down into one value. And you can see unique was used here to get rid of any duplication inside of our list. Okay, so there's an example of enumerables and some of the neat things you can do with them. I'm going to show you even more neat things whenever we talk about list comprehensions. Okay, list comprehensions are going to provide us with an additional way to perform actions on lists. So let's say we want to do what we did previously. We want to double every list item. So we're going to go and create a double list. And to do so, we're going to go for n. And then we'll throw in whatever our list is. Obviously, the list could be a variable name. And we're going to go do. And then we're going to say what we want to do with each of the items. We want to multiply times 2. That's just what we want to do. All right, we can go and output this on our screen. And there's our double list. Let's go and do a couple. Let's go and see what that looks like. And there you can see, doubled all that for us. Pretty neat. Let's say we wanted to create a list of even values. Do that in somewhat easier way. So we'll go n And then we're going to pass in the, let's go 1, 2, 3, and 4. This is going to spit out only evens. So here's going to be our condition. We're going to say the remainder of n, each of the list items divided by 2, is going to be equal to 0. So if it meets that condition, it goes in our new list. If it doesn't, well, it doesn't. So we'll do like that, and we'll go inspect again, and we'll spit that guy out, and that's going to be our even list. There it is, and we can run it, and we can see there's our evens only. And I think that's actually probably enough of list comprehensions. Just play around with it, you'll get it, and they are very, very powerful and very, very useful. All right, let's talk about something else that's useful: exception handling. Now, exception handling is just going to allow us to handle errors. And what I'm going to do here is I'm going to do a very, very simple example. You can go on your own and experiment and test some other things out. Now, anytime you think you're going to do something that could potentially cause an error, what you're going to use is a try block inside of it. And I'm going to store the error inside of here so that we can output some information about what went wrong. I'm going to force a division by 0. Now, that is going to cause an error. So if I want to rescue myself from that potential error, what I'm going to do is throw rescue inside of there, and then I'm going to put the exception that is going to be triggered whenever that occurs. And I leave that to you to go and look up all those different potential exceptions. And what I'm going to do here is I'm going to say that if we hit this, I want to go and put an error on the screen, but not crash the rest of my program. So I'm going to do that, and then we're going to end, we're going to get out of there, and then I am going to output that error message on our screen, and then we'll move on and our program won't crash. So we'll just output that. We'll go over here, we'll run it, and there you can see can't divide by 0, and however we would be able to continue going on and outputting additional information. Okay, I know, very, very brief explanation. Exception handling deserves more time, but I'm trying to keep this short, and I want to jump over now and talk about concurrency. Now, concurrency is extremely powerful. Basically, it is going to allow us to run multiple blocks of code at once. And how you do it is you call a function called spawn, which is going to start a new process that runs the code specified at an undefined time. So what I'm going to do is I'm going to use our loop function down here to create 2 separate processes that are going to run at the same exact time and output information on our screen. And this is how easy it is to do. To create a new process, you just go spawn, and I'm going to go function like that, and then I'm going to go draw an arrow, and I'm going to define what I want to occur in this process. So I want to count from 50 to 1, and then that is going to end that. Now, if I want to create a whole new process, I can create thousands of processes, and Elixir is very, very good at splitting up this time. So I'm going to go and spawn another process. This guy is instead going to count from 100 down to 50. So we are going to be able to see how these are going to work. So I'm going to save that, and let's come over here, and let's run it, and you're going to see. Now what happens is each of these processes gets a PID number, or a process ID. So we're calling this guy 50, it's counting from 50 to 1, this one's counting from 1 to 50. And you can see how they jump back and forth, sharing time, each giving each other time to do all of their work, all on the screen. So these processes are working at the same time and taking turns and doing everything that you could ever want them to do without causing any problems. Elixir is fantastic at doing this. We're also going to be able to send messages between processes. So what I want to do here is I want to actually send a message to this process, to this do stuff process. How can I do that? We can send messages to anything. So what I'm going to do here is I'm going to say send self. So I'm sending this message to myself. And what I want to do here is I want to pass in French and Adam, and I want to pass in the word Bob. You're going to see what happens here. I'm going to be able, in all my processes, I'm going to be able to receive different messages so we can communicate back and forth between processes. And I could do an entire tutorial on how we can do awesome things with this. But like I said, this is just a very, very brief explanation. So I'm going to say if they receive the Adam of German, in that situation, what we're going to do is we're going to go IO puts, and we're going to go Guten Tag, and we are going to output whatever they passed in for our name. And now what I want to do is I want to And this is exactly how it works. You have normally a key here and then values that are passed inside of it. So let's go and do a couple more of these. We'll say if they pass in French inside of there, we're going to do the same thing, except we're going to change this to bonjour. And there that is. And if they pass in English, we're going to respond with hello. So there's hello. Whoops, spell hello right. And there that is. And let's do one more thing here before we finish up the entire tutorial. If there is no matching message, what we're going to be able to do is issue a timeout. Let's say we wanted to do a timeout for, say, 500 milliseconds. We could do that, and we just want to come down here or go before the end, and we'll go outside of here. Yeah, let's go down to the next line. And I'm going to say after 500 milliseconds, if there is no response, well, in that situation, I'm going to say puts and whoops, time up, and that's going to handle that condition in which it didn't understand what was going on. All right, so let's run that. Whoops, hit the wrong button. Run that and run that. And where'd it go? Oh, I know. It went and actually executed it ahead of time. So here you can see Bonjour Bob comes through. We actually passed a message inside of there. And randomly, you know, this could be down here a couple more lines or whatever. But you can see exactly how concurrency works. And I think that is a pretty good jumping off point for you to go in there and explore with Elixir more about concurrency and all of the other different things that I covered in this tutorial. So hopefully you guys enjoyed that. That is a lot of information. And like always, please leave your questions and comments below. Otherwise, till next time.